this is 11.3, sector area and arc length. We'll first talk about what is a sector of a circle and a segment of a circle and an arc length. Arc length, again, is going to be the length of your arc. Okay? It's pretty obvious. Arc length would be the length of the arc. It's the distance along the arc measured in linear units. So that's a new unit of measure. An arc length is measured in linear units. It's kind of like you took a string, laid it around a circle. How long would it be? A sector of a circle is this part shaded in purple plus the part in red. Okay? So sector of a circle is all the way out, the purple and the red. You should be adding this to your circle diagram that you put in your notes. So it will be something that will be on your test. You'll have to label these parts. Then the segment of a circle is this little red piece. Okay? A segment of a circle is going to be from the arc to the straight line that forms the triangle in a sector of the circle. So this is the segment of a circle, this red piece. Alright. A segment of a circle, full definition, is the region bounded by the arc and its chord. You can see it's shaded red. Alright. Down. Now, we can find the area of the sector, we can find the area of the segment, and then we can apply those information as well. We can also then find the arc length. One thing you're going to want to remember in triangles is your special right triangles. When they come up, you will see them here. So remember those special right triangles and your radicals and things like that. Alright, the formula to find the area of a sector of a circle. Sector of a circle, remember, looks like pizza wedge. Looks like sliced pizza. So to find the area, different color, it shows up a little better. To find the area of that sector, you have a formula. It's going to be area equals pi r squared, oh my, it's the area of a circle formula, times the measure of your central angle divided by 360. So basically, it's the decimal version of this measure. Okay? It's also the percentage if you wanted to look at it that way. This part of the formula, you're finding what percentage of the whole pi is that sector, and then you're multiplying the decimal form of that percent by the whole area of the circle. So in other words, you're taking out whatever this piece is. Okay, so that's why the formula works. Alright, so if I'm told that the measure of this sector, the central angle is, say, 80 degrees. It's not, because I didn't draw it very well, but let's just say they told me this was 80 degrees. So to apply my formula, I would do area equals pi r squared times 80 over 360. Okay? 80 divided by 360. I'm hoping somebody's got the calculator for me real quick. Alrighty, so this gives us A equals pi r squared times 0.22 repeating. Okay? Or we could just type in the 80 over 360 into our calculator. It was also given to us in the original problem that our radius was 3 inches. So we're going to plug that in for r. So now we have pi 3 squared times, for accuracy's sake, I'm going to put this as a fraction. Since it is a decimal repeating, it's better to use the fraction. It's a more accurate answer rather than rounding. 3 squared is 9, so I have 9 pi times 8 over 36. You plug that in your calculator and you find out that it is 12 pi. Two pi, my bad. There we go. You get 2 pi, which comes out 6.28. And that is an area, and my area was originally in 3 inches, so then this would be 6.28 inches squared would be your units. You always want to make sure you're putting units on there so that we know we're not talking about cupcakes or butterflies. We know we're talking about inches squared. Moving on to the next example. I'll leave the formula up there. We're going to find the area of the segment. So I found the whole wedge. All right, we're going to be talking about the area of the segment. So instead of the whole wedge, we're just going to find the little sliver at the top. So we've got our wedge, and we're wanting to find the area of that black part right there. Well, the easiest way to do that watch my arm jiggle. I just color that. Awesome. We can find the area of the whole sector using our same formula that we just did, minus the area of this pretty triangle. Because we can find the area of a triangle, area equals base times height divided by 2. And once we have all that information, we subtract the 2, and we'll have the area of just the little black piece. Alright, so on this circle, we know that our radius is 12 inches, and we know that this angle is 60 degrees. This is where you're going to have to remember your special right triangles. Okay? So what I'm going to do is I'm actually going to take this triangle out. Well, before we do that, let's find the area of the whole sector first. Okay? We're going to use the same formula we did before. So again, I'm going to do area equals, can you all see this? Can I go that far over? Okay. Area equals pi r squared. M, oh hello, I know what M is. M is 60 over 360. And my r, I know, is 12. So that means I have 144 pi times 6 over 36. That reduces down to 1 over 6 times 1/6. So when you punch that in the calculator, you end up with 24 pi. And if you're punching in the calculator, you just do 144 times 1/6, or divided by 6. And that leaves it in pi form. You want to leave it in pi form now to be more accurate, because remember, pi is a rounded number. We can't use all the decimals. So just use pi for now. When you get to the very end, we'll actually calculate it. All right, next step, we're going to find the area of this triangle. So I'm actually going to pull this triangle out of the circle. And, okay, so there's the circle. If I have the triangle, okay, so this is my central angle of 60 degrees. Okay, and so remember my arc is over there. Okay. To find the area of this, I have to have the base and the height. Now we knew our base is our radius, right? We also know this side length, but it doesn't really matter. Well, maybe it does. Who knows? Let's see. 12 inches. Okay, so I've got 12 inches here. Because this is also a radius, that makes this one 12 inches. There we go.
And then it makes the other side 12 inches. Oh,
well, we don't know. But I do see a right triangle, and I do see a special right triangle. If this is 60 and this is 90, this has to be 30. Then you go back and you remember your special right triangles. Oh, before I get there, if this whole thing is 12, this side and this side are each 6. So you can use Pythagorean theorem to find it, but you don't have to. Remember your special right triangle rules? S, 2S, S radical 3, which one's which?
S.
Alright, sorry for that little break there. Didn't want to have student voices in there. Our special right triangle, we've got S at the bottom on our short side of 60. S radical 3 is our long side. Our hypotenuse is 2S. We know that matches because this side is 6 and this side is 12. So S is 6, 2S would be 12. Therefore, making S radical 3 is going to be 6 radical 3 is the height of my triangle. So I can now do base times height divided by 2 and find the area of my whole triangle. So base times height divided by 2. My base is 12, not 6, 12, the whole thing, times 6 radical 3 for my height. all that over 2. So when you punch that in your calculator, you get 36 radical 3, that's 12 times 6, okay? All that divided by 2. 12 times 6 divided by 2 is 36. So I have 36 radical 3. Okay? Then I plug it into my calculator, 24 pi, which was the original area of my whole sector, minus 36 radical 3, which is the area of my triangle, equals 13.04 inches squared. Okay? So that's how you do that one. This part right here is where you just punch in your calculator. Okay? We'll wait till the end so you don't round off any decimals. Alright? Solve. Alright, last one is how to find the arc length. It's simply applying the formula. The formula to find arc length, which is used by a capital L, is 2 pi r, look at that, it's the formula for circumference, times the measure of the angle over 360. Again, it's basically taking your whole circle, finding this, okay, measure of your central angle degree, or not your measure of your central angle degree, I'm sorry, we're not doing central angles, are we? My bad. Talking about the arc. Okay? This will be given to you in degrees. So say this is 90 degrees of the circle. Okay, it's not. That would be 90 degrees of the circle. Okay? If I know this is 90 degrees of the circle, I can find what portion of the whole thing, multiply that by the total circumference, and that'll give me the piece of it. Okay? And it'll give it to you in linear inches. Okay? Rather than in degrees. So I know this is 90 degrees of the whole 360. I plug it into the formula, and I get 2 pi, this is 10 by the way, 10 feet. And I know 2 pi times 10, all that 90 over 360. I get 20 pi, 9 over 36. So I cross off my zeros. 9 over 36 is going to give me 1 over 4. 1/4 of 20 is 5 pi. So you punch 5 pi into your calculator and you get 15.71 feet. And so that's how many linear, if I needed an actual string to lay on the edge of my circle, that's how much it would be. Alright, and that's all she wrote.